Hello and welcome to ETech Video Production. Let's go back in history. Back in 1984, Cisco developed their first dynamic routing protocol called EIGRP, or Interior Gateway Routing Protocol. 8 years later, Cisco developed Enhanced EIGRP as a dynamic routing protocol also to overcome the limitation of EIGRP, such as classful network only and distant vector routing protocol. This video is the overview of 6-part video segment on Cisco EIGRP. Since the development of EIGRP, many new technology has emerged as well as evolved. For an example, our LANs and WANs bandwidth has drastically increased from kilobit per second to now hundreds of gigabit per second, where the delay has decreased from second to micro and soon in picosecond. To accommodate for such changes, Cisco EIGRP also has to evolve. To fully cover EIGRP and its evolution, we have to break up the lecture into 6 video segments. So let's review what's in these segments. Segment 1 is the fundamental of EIGRP. Here we'll cover what is EIGRP, why the development of EIGRP was necessary, and what makes it special over other dynamic routing protocol. Next, we enable EIGRP using basic configuration, and last we'll go through how does EIGRP works. Segment 2, the advanced configuration of EIGRP. Using the same lab as in segment 1, we will reconfigure it but using more advanced configuration techniques. Then perform some fine-tuning such as passive interface, summarization, injecting a default route, perform authentication, and EIGRP stub. After that, we'll take a look at a few best engineering practices when implement EIGRP, and finally the question I have been asked so many times, why should we use EIGRP for our interior gateway routing protocol? Segment 3, the deep dive into EIGRP. In this segment, we'll start first with the path manipulation. By manually alter the bandwidth and the delay of an interface, and with the use of offset list, we can influence how EIGRP select a different path to a remote network. In routing, the term load balance is the router capability to load sharing over 2 or more interfaces to the same remote destination network. But there is a condition. To load balance, all those interfaces must have the same metric to the remote network. EIGRP is the only routing protocol that can actually load balance over unequal metric paths. Using the variance command, we'll enable that and see how that works. And last, with the use of distributed list and route filter, we'll demonstrate how to filter incoming or outgoing of a route advertisement. And the deep dive continue in segment 4. When companies merge or just performing a partnership, or just straight cloud computing to Amazon AWS or Microsoft Azure, the routing protocols between these companies will likely not going to be the same, and this is where redistribution come into play. We'll go through how to share routing table between different autonomous systems or from one routing protocol to another using redistribution. And while performing redistribution, we can control what to send, what to receive with the use of route map, prefix list, and route tag. Segment 5 is name mode EIGRP. Back in the EIGRP day, the norm for bandwidth is in kilobit per second. Anybody remember the modem days? To T1 of 1.54 megabit per second. But as soon as bandwidth increased to the 10 or the hundreds of megabit per second, Cisco have to take the original EIGRP diffusion update algorithm and multiply that by 256 so EIGRP routers can distinguish the difference between megabit per second to gigabit per second. But now these days, anything above 10 gigabit per second, EIGRP, now referred as classic EIGRP mode, just cannot tell the difference. Beginning of their iOS version 15, Cisco introduced the name mode EIGRP. Briefly, name mode allows EIGRP to run something called Y-metric calculation. That Y-metric calculation allows them to overcome that problem with above 10 gig per second. But it also improves other things such as simplify the configuration, having the capability to run dual mode, which is running both IPv4 and IPv6 under the same autonomous system, have a better hashing algorithm than that MD5 for authentication, and create a more defined hierarchy to support multiple protocol or emerge new technologies such as virtual routing and forwarding. We will go through the detail of name mode EIGRP and its configuration, and last we'll convert a classic mode EIGRP to a name mode EIGRP. In last segment 6, continuation of name mode, we will cover virtual routing and forwarding, followed by over-the-top EIGRP. Virtual route forwarding is the technology that supports multiple routing instances inside a single router or a layer 3 switch. What this means is a single router can have multiple separated routing tables, and each one is completely independent of each other. We'll demonstrate how to do that with EIGRP name mode. And over-the-top EIGRP is a feature that enables site-to-site EIGRP operation, as it can function transparently or privately on top of a public WAN connection. I do want to thank you for spending time watching this overview video on our Cisco EIGRP tutorial. Please subscribe to our video channel and view all 6 segments of EIGRP as well as other technologies. Till then, stay safe, and I'll be looking forward to share more information with you in the next video segment.